that we call K. The second one is distribution factor. Distribution factor is the portion atau is the division of the summation of stiffness. The first thing is stiffness. The second thing is DF, distribution factor. Is the portion or is the division of stiffness. And the last one is carryover factor, COF. The carryover factor for moment distribution is fixed, which is set to be 0.5. So basically, in summary, there are three things lah. The first thing is stiffness. Second thing is distribution factor. And the last one is carryover factor. Okay, Usam, can you repeat, Usam?
Sorry, doctor, repeat what?
Can you repeat that I explained with you? There are three basic things that you should consider.
Oh my god. Unfortunately, doctor, because I was recording because I was heading to the car, so I wasn't hundred
Okay.
percent focusing. Sorry.
Adam, are you listening, Adam? Adam, are you listening?
Ya, dokter.
Boleh repeat apa yang saya cakap tadi?
Baik, dokter.
Hah?
Apa-apa dah, sini bising sikit.
Ada bising sikit. Okay. Aris boleh repeat, Aris? Aris, ada ke Aris? Atta? Oh, Atta. Repeat apa yang saya kata tadi, yang ada tiga benda tu.
Member stiffness factor, distribution factor dengan carryover factor tu kan doktor?
Ya. Lepas tu dia punya yang ketiga-tiga tu, kamu kena ingat lah. Dia punya ketiga-tiga tu, kamu kena ingat apa itu, what is the K, what is the distribution factor, carryover factor. Okay. This is the very basic thing. Three things that you should calculate, you should consider in order to solve the structure by using the shape of the dimension of the members lah, that you should be considering either it is a general or sideway or non-sideway frames. So basically, the moment distribution method is what we call is the cross method lah. Is the one that is we call cross method. Cross method for RC. For RC. Why it is only be applied for RC? Because all of the support for RC, we can only design it for fixed support. We can only design it for fixed support. So basically in steel, we can design it for fixed support, but it's hard for you to construct it. Why? Because you have to hang the beam, the steel beam, before you're going to weld it. If you are using bolt and nut, so basically your structure is designed to be pin if you are using bolt and nut. So in order for you to fix in steel structure, you have to use welding connection. So basically the RC, their special method of analysis is this one lah, moment distribution method, or the one that we call cross method. So basically, it can use to analyze continuous beam, continuous frame by taking into the account the bending deformation lah. So this is classified as displacement method. Why displacement method? We have to mention it. We have to taking out dia punya slope and dia punya theta, which mean you have to consider the parameters of the some kind of parameters lah we're going to be covered soon, such as elasticity, and I is what we call apa itu I ya? Modulus I BH kuasa 3/12. Apa itu I ya? Din, apa itu I Din? Moment of inertia, nasilap. I is moment of inertia. B is the shape. H kuasa 3, BH power of 3/12. Moment of inertia, I think. EI over L. K is what we call EI over L, or we call it stiffness factor. Okay. So unlike slope deflection method, that's why I said if we jump one of the method that we should cover first, there are some kind of missing lah. There's some kind of missing that you're going to a bit confusing lah. But no worries, I try my best to solve the problem lah, to make you all understand in a better way. But this one you can read yourself easily lah. This apa nama itu, moment distribution method is actually the very easiest method to solve it. But since we already skip one method before the moment distribution method, so basically there are some kind of method that we call slope deflection method that we already skip. There are some kind of parameter lah, but I try to explain with you lah nanti lah during the tutorial. So the method of the moment distribution ni, you have to imagine all the structure held. Makanya they can rotate and compute the moment at the end of the member. So in order for you to use the moment distribution method, the very first thing, your connection is fixed support. If your connection is not fixed support, basically they are not going able to be used lah with this method, because this special method is designed for the RC. So the connection shall to be in fixed lah. And then each joint distribute the unbalanced fixed end moment among the connecting members in proportion at the constant for each member defined as stiffness. So definition of the stiffness yang ini lah. This one is the definition of the stiffness. You all have to understand it. For instance, in final question number 1, theory, define stiffness. You can copy paste this one lah. Guys, understand this paragraph, and then you can answer the final exam lah. Define the stiffness, define the modulus of elasticity, define the moment of inertia of the beam. That's some kind of the very basic things lah that you should able to master it. And then multiply the moment distribute for each member at the joint by the carryover factor. Carryover factor ni, we have to set it, COF is 0.5. 0.5 because this one already been set by Eurocode 2. Eurocode 1 is about can someone explain to me what is Eurocode 1, Eurocode 0, Eurocode 1, and Eurocode 2? Eurocode 2, we design it for RC. Eurocode 3, we design it for steel. What is Eurocode 0 and Eurocode 1? Can someone explain to me? Boleh, Azrin. Apa Eurocode 0, Eurocode 1? Kamu sudah belajar RC kan? Introduction. Oh, Azrin.
Dokter apa?
one euro Eurocode 0, apa function dia? Apa function Eurocode 1? What is the function of Eurocode 1? And then what is the function of Eurocode 0? I think Dr. Andrew already explained to you lah what is the function of Eurocode 1, what is the function of Eurocode 2. Eurocode 0. Eurocode 2 is the one that we design the beam. And you find the K balance, you find the K less than K bar, you find the K more than K bar. If K less than K bar, and then the compression reinforcement is not required. If the K bigger than K bar, then reinforcement compression reinforcement is required. I think you already study by explained by ini kan Dr. Andrew, right? Apa itu Azrin? Eurocode 0, Eurocode 1. Come on guys. RC nih. RC, if you cannot understand your basic, oh malu ya MS.
Eurocode 0 for foundation and Eurocode 1 for actions, which is yeah, and 0 for foundations.
Eurocode 1?
Eurocode 0 for foundation and Eurocode 1 for loads.
A bit closer. Good effort to some. Can someone add on? Anis, boleh tambah ke Anis? Anis, can you back up Husam? Anis? Anis?
Ya dokter.
Backup Husam, Eurocode 0, Eurocode 1. Anis, aku tunggu nih.
Sorry dokter, apa tadi?
Define Eurocode 1, Eurocode 0. Hai guys, kamu tidak ada basic Eurocode, macam mana kamu mau design? How can you design if you don't have your basic? Capika, apa itu Eurocode 0, Eurocode 1? Ivy. Eurocode 0, Eurocode 1.
Eurocode 0 pasal safety and design structure. Eurocode 1 lots di structure.
Okey lah. Boleh lah.
Mantap.
Okay, and then you have to multiply the moment distributed to each member at the joint by the carryover factor. Carryover factor is fixed to be 0.5. COF fixed to be 0.5. The K1 that we call stiffness, you have to find it. The F also we have to find it. Okay, and then repeat the process until the moment to be carried out over a small to be neglected. They are small to be neglected ni, which mean they are near zero lah, near zero or plus minus zero. If you get 0.5, and then you can stop lah, 0.5, 0.2, 0.3, until it is near to zero lah. Repeat the process. The process, the moment distribution method is the very simplest method lah, actually in the TOS2. It's the very simplest method, and this method also the very common one that structural engineer used to design or used to recalculate your moment, or used to recalculate your in order to check up the design that you found by using the software. And then you all can read this easy lah, just very easy. And then the second thing is the sign convention. Sign convention, it is not fixed. During the final exam, you have to read the question lah. You have to read the question. Either it is assumption, clockwise, positive, or the anti-clockwise is positive. So in this slide, the clockwise moment are considered positive, which means the moment that going to rotate clockwise are considered positive. The one that counter it is considered negative. So basically in your final, read the question carefully. Either anti-clockwise is positive or clockwise is positive. In your projection also, you have to consider it. You have to assume it. Either it is clockwise positive or anti-clockwise positive. Depend on your preferment lah. That you prefer either clockwise positive or you prefer anti-clockwise is positive. It's depend on you. But in final, read the question carefully. Read the question carefully. Okay, the first thing you have to find the fixed end moment lah. The fixed end moment ni actually you obtain through the appendix. The formula you can obtain through the appendix. So FEMBA from this slides, this one B to the A is equal to the positive one, and this one is equal to the negative sign because it is anti-clockwise. This one is positive, this one is negative. The very first thing is you have to analyze the fixed end moment. The fixed end moment for the point load is equal to FEM PL over 8. P is the point load, L is the span length. Meanwhile, you have to divide it by 8. So 800 times 10 over 8. You obtain 1000 Newton meter. Refer to the assumption. Either your assumption is anti-clockwise or clockwise. And then you make the sign lah. You make the sign for the FEM B to A and FEM B to A. And then the second thing, you have to find the stiffness factor. Stiffness factor, the equation you have to memorize is K is equal to 4 EI over L. K is equal to 4 EI over L. Listen carefully. During the tutorial, I'm not going to explain to you again. I'm just going to be fluently. We're going to be fast because I'll already explain to you during the class. So K is equal to 4 EI over L. Is equal to EI over L. So E actually is the modulus of elasticity. I is the moment of inertia divided by length of the span. Divided by length of the span. Okay, this one is we call the joint stiffness factor. Joint stiffness factor is the one that we summation of the, okay, this one is the joint A. Joint A is connected by beam B, D to B, and then beam and the column A to C. So this one, the joint A is the what we call the stiffness factor. They have the joint stiffness factor at A. So the total stiffness factor is the KT is equal to summation of the K. So KAD is 1000. AB is 4000 and KAC is 5000. You just have to sum it. You have to total it. So K total, stiffness total is in this diagram is 10,000 lah. 10,000 summation. You have to only add all of the stiffness factor. Okay, the second step you have to find it distribution factor. This distribution factor is the second thing that you have to memorize. Stiffness factor, distribution factor is the one that we call the fraction of the total resistant moment. So the definition of the distribution factor is the fraction of the total resisting moment. Fraction of the total resisting moment. So basically distribution factor is equal to over moment. This one is M is the total moment, or K times by theta is equal to summation of theta and KT. We will cover it in tutorial soon, but this formula, this is the general formula that been given in your appendix soon in final exam. You have to able to define this one lah. What is the M? M is the one is the total moment. What is the MI? MI is the KI over theta. This one you should be able to define it yourself. Study it first before you're going to for tutorial next week lah. And then it K. Distribution factor is the K over total K. And then the last one, you have to find the last one is actually the carryover factor. The carryover factor is fixed 0.5. COF is fixed for 0.5. So this is the what we call the formula lah that been given in your final. Distribution factor is equal to 1. So the fixed end distribution factor is 0, is set to 0. If the pin connection, the distribution factor is set to be 1. So the rotational stiffness, this is the formula lah that you're going to be used. So basically, in normal condition, there are only two lah. Far end is fixed or far end is pin. So no more roller because impossible for the RC structure to be installed roller lah. It is totally impossible. The pin one is quite impossible juga because usually the RC we only focus for the fix lah. The RC structure we only focus for the fixed end. But for the pin, sometimes maybe in tutorial we can cover it, but in real construction, it is rarely to be used lah for the pin connection. And then you determine the carryover factor. Carryover factor is fixed end always 0.5 or 0. 0.5 or 0. And then calculate the fixed end moment. This one we will cover in the tutorial lah, so no need to worry. No need to worry. And then this one, yalah, in tutorial lah soon. Very easy ini, no need to worry. Okay, I think that's all from me. You have question?
No.
Ilman, okay, Ilman? Ilman? Oh, Ilman.
Ya, dokter. Hello.
Kau di mana? Makmal?
Ya, dokter.
Kau di Makmal?
Ya, dokter. Terima kasih.
Apa kau buat nih, Ilman, di Makmal?
Orang kasih keluar tanah dari obat.
Okay. Husam? Where are you, Husam?
I'm in the foyer, doctor.
Grade 4 year. Okay.
Yes.
Marian? Marian?
I'm in my room, doctor.
Okay. Okay, Din. Sakit kah?
Oke, sudah dokter baru makan obat.
Okay, we're going to cover the tutorial soon now. Oh, Samira. Okay, Samira. Siapa yang cakap nih? Oh, okay. Si gosip. Ya. Saya nak tegur satu benda saja. Someone is teaching. Concentrate, fokus. Kita tidak tahu, we don't know apa yang akan terjadi pada kamu kalau kamu tidak akan fokus lah. Kalau in case someone is getting angry, someone is frustrated, even it is online. I'm warning to you. I'm not going to, saya tidak ambil hati ke apa. Tapi in case kalau jadi apa-apa, in case kalau ada aduan ke apakah, saya terus terang saya cakap, student, inilah sambil lewat. Boleh ya? I'm trying my best to make you understand. So, you giving me your attention 100%. Sofia? Understand nggak, Sofia?
Faham, dokter.
Hah?
Faham.
Jadi yang geng-geng di pergi Tawau ni tidak masuk kelas kan ni kan? Ada 4 orang itu. Safika? Okey kah Safika? Safika Ratwell.
Oke, dokter.
Okey ya. Ini last thing saya pesan dengan kamu. Saya terus terang. Saya tidak ambil hati tapi jaga. Saya terus terang. Kita gurau. Bila kita belajar. Boleh ya? Anis. Lama saya tunggu kau Anis. Kau ingat saya apa? Pembantu Makmal.